Good morning from the United Kingdom. My name is Diana Contreras. I'm Research Associate at Newcastle University for the project Learning from Earthquakes. This is the outline of the presentation. On the 22nd March 2020, an earthquake struck the city of Zagreb. One person died and 26 were injured, while 2 people more died during cleanup operation afterwards. This was the first earthquake that happened during the lockdown imposed by the governments to stop the spread of the COVID-19. Therefore, people they did not know if they should stay at home or evacuate after the earthquake and been exposed to the virus and the low temperatures. The lockdown made it impossible to deploy an earthquake recognizing mission on site. Therefore, it was necessary to undertake a remote mission supported by monitoring and analyzing social media platforms such as Twitter, Instagram, and Lastquake app. The main aim of using social media is to extract useful information from image and text data, to support data-driven decisions in emergency response, post-disaster need analysis, earthquake reconnaissance, post-disaster recovery, and preparedness. To analyze text data contained in tweets, posts on Instagram, and comments from Lastquake app, we use sentiment analysis. Sentiment analysis is a natural language processing technique applied to determine data polarity. In case of an earthquake, most of the text data will have a negative polarity because it will contain words related to damage, fear, and anxiety. However, there will be also data that include words related to event, such as magnitude, intensity, or the epicenter location that will be considered neutral. Other data will contain solidarity messages, announcement of support with humanitarian aid, or description of help. These are considered to be positive as they demonstrate instances of success. Topic analysis is another natural language processing technique to automatically extract meaning from text by identifying recurrent themes or topics. Based on the study of datasets related to the earthquakes in Albania in 2019 and the Aegean earthquake in 2020, we identified 12 categories. Here you can count only 11 because the category of tsunami does not apply for the case of Zagreb. Sentiment analysis has been mainly used for customer review of products and places, but in this research we use it for assessing emergency response and early recovery. Monitoring social media such as Twitter, it is possible to identify the hashtags related to the event. The final hashtags chosen are in this second box. After that, we start with the data collection. Here we can see the amount of data collected from Twitter and the Lastquake app. Some tweets, posts on Instagram or intensity reports have comments but no pictures, or the other way around. Well, in this presentation, we focus on those entries that include both image and text data. Pictures in social media platforms are not geotagged anymore due to privacy issues. Then, to be able to use image data, we need to georeference it, looking at landmarks, at the name of the streets, or contact the photographers to know the coordinates where those pictures were located. And finally, validate these coordinates using the Street View function from Google Maps to finally produce a map with the spatial distribution of damages in Zagreb and surroundings. We georeferenced 19 pictures from Twitter. Here we can see that the reports were concentrated in the city center. Then we make a zoom, and finally we can see the tweets and the pictures uploaded to this platform from users related to the event. Instead, the intensity response from the Lastquake app are already georeferenced. Now we make a zoom on the intensity reported in Zagreb, and finally on the spatial distribution on the intensity reports with contained image and text data. Again, we observe that the damage or the reports are concentrated in the city center, but we see reports from other locations around the city that we do not see from Twitter users. We may again zoom on the city center, and finally we can see the intensity reports with the text and image data from users. Then coming back to the methodology, after eliminated those tweets from the 20 and 21st March, we looked at a sample of 10% from then, and we focus on the analysis of those containing image and text data. Only 45 intensity reports from LastQuake app include both pictures and comments. After data is collected, is extracted, it's necessary to process it and proceed to the extraction of keywords. The word cloud, which is a method for keyword extraction, indicates the area affected, the problem represented by the COVID-19, that there was a damage, the most affected facilities, hospitals, the population affected, newborn babies, and who were involved in the emergency response. After keywords are extracted, we proceed to the classification of text on polarity and topics, focused mainly in emergency response and early recovery. As the result, in this table, we can observe that the result of the polarity classification shows that it's mainly negative, as expected, because it's an earthquake, followed by positive and neutral from both, but no positive from LastQuake app users. Here we can see the spatial distribution of the polarity across the city, and here we can see the epicenter of the event. And here we can see we can have a zoom on the city center. Then, in this table, we can observe the results of the polarity classification of the text data. In the case of Twitter and Instagram, mainly seismic information followed by building damage and emergency response. In the case of LastQuake app, mainly intensity, the topic mainly address was intensity followed by building damage. This is because this app is developed for that, to report intensity. If we focus on emergency response, because we couldn't find any comment related to early recovery, we see that the assessment is acceptable, considering that, okay, the majority of the highest polarity is negative, but is followed by positive, and not that far. Then here we can see the distribution of the topics across the city, the zoom in the city center, and we can conclude that the users of the different social media platforms have different profiles. Therefore, text and image data, polarities, and topics concerning the same event can vary according to the platform. Twitter and Instagram were created to share general information. That is why it is possible to identify different topics addressed on the data extracted from these sources, which is useful for situational awareness. However, few pictures on this platform include pictures of damages inside buildings or several pictures of the same building, which does not help for building damage assessment. For instance, the focus on building damage, geotechnical failures, and seismic intensity of pictures and comments from LastQuake app users can be explained by the fact that this app was specifically developed to share information about failed earthquake and seismic data. Then, the data provided by coming from this platform is really useful for damage assessment. The percentage of confidence with which an algorithm classifies text data rise when the intensity reported is higher, because users tend to include fewer words, making the classification more precise. Citizens as sensors should be trained to provide more useful data for emergency response and earthquake reconnaissance. These were the main references. Thank you very much for your attention.